Our objective today is to continue graphing equations. We're going to, so that's one thing, we're going to understand the terms, so we're going to do some vocab. Linear equation, we talked a little bit about that yesterday. We're going to talk about x-intercepts. We're going to talk about y-intercepts. Let's see if there's anything else I want to put on there. Ooh. Standard form. Oh, wait a second. Let's put them underneath here. Oops, go back. Standard form of a linear equation. Horizontal lines, and vertical lines. And their graphs. Okay. So let's do some vocab. Get that out of the way so we can make sure we understand everything, and then we can start using it. So linear equations. We talked about that yesterday. Can you, looking at your homework, would you say that the equations you had were called linear equations? All of them? Yes? No? Okay. And I'm going to say the answer is no. Which equations from last night's homework would not be considered linear equations? Molly? Okay, so that those last three, right? We had a parabola we graphed, we had that V shape for the absolute value that we graphed, and then we had the asymptotes, okay? So, but everything else were linear equations. What was the dead giveaway that they were linear equations? What we did for the rest of it. Let's see, Brian.
Yeah, well, a line.
Say again?
Yeah, well, a line.
So when you graphed it, the graph was a line. And that's what makes a linear equation a linear equation. So if you look at linear, and you look at the first four letters, it's describing what you're going to be getting. Okay, so a linear equation is an equation whose graph is a line. Okay, so again, most of what we graphed last night focused in on linear equations, and if you think about back to our notes, it was all linear equations. Okay, so let's talk about a linear equation. So I'm going to go to the next page, and I'm going to bring up my special graph paper. All right, so fancy graph paper. So I'm going to kind of do my graph just off to the side so that we can add some notes. Okay, would you guys all agree that that is called the graph of a linear equation? Yes. Yeah, because we end up getting a line. Okay, now, what are some things you notice about that line that we drew? What are some things you can tell me about that graph? Serena?
They have arrows on the end.
Yep, we've got arrows because, again, lines go on forever. Okay, what else? Ethan? And it does have a positive slope. Good, even though we haven't even talked about slope, that's good. The way it's facing is considered positive. And we'll talk more later about what that means. What else? What else do you notice about that line that we drew? Ian?
There's not at the line, but there's X and Y coordinates on the graph.
What do you mean?
Like, you have to put the X and Y coordinates.
Oh, yeah. That would be standard graph. I'm kind of focused in on the line itself, the red line. Okay. Anything else that you guys can tell me about it? Okay. Oh, we got another one, Jason.
Like, describe the line?
Yeah.
Oh. Not a straight line?
Okay. Well, here's the bottom line. Are there any other kind of lines other than straight ones?
No.
Okay. So a straight line is kind of redundant. Okay, because a non-straight line is not a line. So, no, I get this all the time, and it just kind of cracks me up. All right, let's try. How about if I give you this perspective? Look back at the vocab,
Oh my.
and is there something from that vocab that you can see in this graph? Miles?
It has no label.
Okay, I just haven't put them in there. They're there, they're just not labeled in. Sarah?
It doesn't go through the origin.
It does not. Do lines have to pass through the origin? If you look at our homework, we had a ton of them that didn't, but we do have several that will, okay? All right, something that's from the vocab that was in our top of our objectives that may relate to this particular graph. Maggie?
It intersects in the X and Y axis.
Yeah, if you notice, the red line intersects the x-axis and it intersects the y-axis. How many places does it intersect the x-axis? Once. That would be this point right here. I'm going to color him green. Get my Christmas on, right? This is called the x-intercept. It's the where a line intersects or crosses the x-axis. So let's take a moment. Now notice I haven't put any labels here in terms of tick marks, and I know what I'm counting by. So if somebody says, okay, I need you to give me the coordinates of that particular x-intercept, what would the coordinates of that x-intercept be? So in general terms, we can use x and y as our numbers, okay? So what would you say would be the coordinates of the x-intercept? Brian?
1, 0.
Okay, again, we don't know if it's 1 or 15 because I haven't put any numbers there, so we're generically going to use, for numbers, x and y. Okay, so with that in mind, what would be the coordinates of that x-intercept?
That's 1.
Does it intersect the y-coordinate? There's a y-coordinate for that one? Okay, Serena?
X, 0.
Okay, if you notice, it crosses the x-axis at some number x. But it doesn't go up or down from the origin spot, so the y-coordinate actually is 0. Okay, that's going to be true for all x-intercepts. That where they cross, it's not raising from the origin up or down. So the x-intercept or the y-intercept or the x-intercept's y-coordinate is always 0. Okay, I like always. It's predictable. Okay, so let's focus in on this guy. And he's going to be called the y-intercept. And a description of the y-intercept would be where a line intersects the, now this time, y-axis. Okay, so let's turn the tables. Now again, I have no numbers written on my axes, so if I can only use x and y as my coordinate values for the x value and the y value, what would be the coordinates of the y-intercept? Okay, what would be the coordinates of the y-intercept? Charlie, what do you think?
0, y.
Exactly. Notice that it doesn't go to the right or left of the origin. It's at the 0 spot for the x. So this 0 is always there. What is going to change is the y number will change depending on where it crosses the y-axis. So that's what intercepts are. It's where the line intersects the axes. The x-intercept, in particular, intersects the x-axis. The y-intercept intersects the y-axis. Okay, Miles, you have a question or statement?
That's another thing about the line.
Okay, what else?
It doesn't, the only quadrant it doesn't pass through is quadrant number 2.
This particular line, yes. Okay, this particular line. Do you think it would be possible to draw one line that crossed through all 4 quadrants? Now here's the deal. If it's on an axis, it's not in a quadrant. It's on an axis. Okay? So it looks like we can get it through 3 quadrants. And if I did another one up here, I can get it through 3 quadrants. I could get it through 3 quadrants eventually. But it doesn't look like I could get through all 4. Okay, so interesting observation about that particular one. All right, let's get rid of those so that we don't confuse people. And Lucas.
Could you possibly call the coordinates for the y-intercept 0, negative y?
Again, generically, y is going to be just representing a number on the y-axis. Whether it's positive or negative gets plugged in depending upon where that actual point is. So I'm not going to use a sign label. I'm just going to use y as my coordinates. Okay? All right. Any questions on that? Okay. So let's talk about standard form real quickly. So we'll go to the next screen. And we'll lose our pretty paper. And let's talk about standard form, and then we'll be able to show you a new strategy for graphing. Linear equations. Now, I'm going to specify that we have several standard forms depending upon the equation we're talking about. Alex, we're taking notes. So standard form, this is specifically of a linear equation. You saw several examples on your homework last night, and you also saw several examples of the equation where y was just by itself. So standard form looks like this. Okay, so seeing an example, what would be some key ideas about standard form of a linear equation? What are some things that you notice? Okay, Amanda, one thing.
The y isn't by itself on the x side.
Okay, so the x and y are together. Can we say that? And I'm going to be very specific on the left. What else do you notice? Miles?
Both the x and the y have coefficients.
Okay. I'm going to say that's true. Because a coefficient could be 1. And a coefficient could actually be 0. Now, describe the kind of coefficient on the x and the y. And I'm going to tell you what you see here. Those particular types of coefficients are the only types of coefficients allowed with standard form. So what do you notice about those coefficients? What kind of numbers would we describe them as, Aiden?
Even.
Okay, true, but that's this particular case. Okay, Maggie?
Whole number.
They're whole numbers, okay? Now, let's deal with the notion of they could be positive or negative. So what do we call numbers that are whole or positive or negative? Okay, I think I heard Spencer say it. What was it?
Integers.
Integers. So coefficients on x and y are integers. What kind of number do you notice the constant is? By the way, which one's the constant? The 7, right? What kind of number is he? Whole numbers. Now, in this particular case, he's positive, but he could be negative, so we can also describe him as an integer. Okay, so the constant is an integer. All right, anything else that you can see in that particular equation? Because this is our role model for what all standard form of linear equations look like. So far we got x and y together on the left. The coefficients on the x and y as well as the constant are all integers. So I can put a little no fractions or decimals. That's the opposite of integers. Okay, anything else? Positioning. Look at your variables. Maggie?
X.
Yeah. X has to be in front. So we'll say X comes first. And if you think about it, it's just alphabetical. Now, the last thing I'm going to mention is a judgment call. Okay? Look at the sign on X. What sign does X have? Positive. And that is the customary way to write standard form, is that your X term is positive. So if your X term was negative when you solved it, you would have to divide everything by -1 or multiply everything by -1 to make sure X was positive. Everything else can be negative, but he needs to be positive, okay? Now, that is not a hard, fast rule. People will write it so that the X is negative. I've seen it more often, though, with it being positive, okay? So this is just one of those you have to be aware of. And so I'm going to write it this way. X is customarily positive. I would not take points off for that, but I'm going to take points off if you leave me any fractions. Okay? Alex, are you taking notes? Because your hands are always in your lap every time I look at you. Okay? Okay, now that we understand this, I'm going to give you a different way to graph a linear equation. And I think I'll bring up my pretty paper. So, graphing linear equations using intercepts. How many intercepts at maximum can a line have? How many times can it cross the x and y axis? 2, right? And is that a safe way to graph when we only have 2 points? Not really, because we'll always get a line, but we may have made a calculation error and we may not know that we have a mistake until it gets graded, okay? But this is a way that we can do things, okay? So number 1, we're going to find the x-intercept of the equation. And how would we go about doing that? So let me give you an equation. Let's make it negative 3x plus 4y equals 12. By the way, these don't all work out pretty, just to let you know. Okay? What did we talk about the x-intercept? What are the coordinates of the x-intercept? So we're going to remember this idea. So in our equation, what we're going to do is take negative 3. We're going to keep x as x, because that's what we're trying to figure out, is what does x equal. And then we have plus 4, but we're going to replace y with 0, and that equals 12. So really what this boils down to is negative 3x equals 12. Divide both sides by negative 3, we get x equals negative 4. So we would say the x-intercept is at negative 4, 0. This is why people like to use this method, because the numbers work out kind of nicely. But did you notice how my equation was written? Must be in standard form. Okay. Amanda, you had a question?
Was this what I was talking about yesterday?
Yes, this is what you were talking about yesterday, exactly. Next, we're going to find the y-intercept. I guess I didn't need my pretty paper yet. The equation. And remember, what were the coordinates of the y-intercept? 0, y. So we're going to take our equation, and where we see x, we're going to replace with a 0. It'll come back. And our y value is our y value. So what we get is 4y equals 12, and we divide both sides by 4. Notice I never do stuff in my head. And I would write the ordered pair, 0 for the x, 3 for the y. And then our last step would be to graph the two pairs, or graph the 2 points. So I am going to do a little graph here. This is kind of an interesting one. I need to go up 1, 2, 3, 4. So my 2 points were at 0, 3. There's my y-intercept. And at negative 4, 0. There's my x-intercept. And I connect them up. Okay. Now I'm going to actually pause right here, and we're going to have to deal with horizontal and vertical lines tomorrow. Okay, I'm going to probably have you guys explore it on the homework though.